Yeah, so thank you very much for inviting me for the story about everything somehow. And so we have a lot of topics, and we will see how far we get on, and they are modular. So if you don't understand one of these chapters, don't worry, I think you will understand the next again. You can have a second go in the next one again. And I could also skip something if you say this is not of interest for us. So we will start with the introduction, Understanding the Cosmos. I think it's a deep innate sense of mankind that we want to know what is the ultimate reality to which we refer, what are the essential elements to which our universe can be reduced, where do we come from, where do we go to? Like Calvin and Hobbes, I wonder why man was put on earth, what's our purpose, why are we here? And the tiger answers, tiger food. So unfortunately, the universe does not speak to us, so we need to think about that. And in antiquity, we have a lot of different creation myths in all ancient cultures, actually. And often it's a fight between deified principles, or the Greeks who started from classical elements. I have heard that Thales actually was the prototype of all theoretical physicists because he was so obsessed about thinking about the basic elements of the universe that while he was thinking, he didn't realize that there was a well next to his foot, and so he fell into the well, but he was saved and could continue to think. So that's the origin of all theoretical physicists, I think. And you see different elements are taken to be the origin of our world here. Even Democritus and Leucippus, they already postulated that everything is just atoms and empty space, which comes close to modern-day naturalism, actually. And I think man has always been fascinated by the dimensions, by the vast dimensions of the cosmos, by the dependence of the cosmos, like without sunlight, there is no warmth, there is no light, and by the regularities that could be found, like Stonehenge. Quite a few people think that Stonehenge might have been an ancient clock for organizing the months around the sun circle. There are most recent theories about Stonehenge, that Stonehenge is actually connected to the Easter Islands. It's just on the other side, and it's actually... That's an intriguing theory, think about that. But there are other theories as well, that the clock had to be reset every half a year, and that was not so easy. Okay, yeah, so measuring the world and the universe has already started in antique times, actually. The Phoenicians already, when they saw a ship at the horizon, they saw that it appeared from top to bottom. So they had already the notion that Earth can't be flat, but must be a sphere. Also Aristotle, he observed the shadow of Earth on Moon and found out that it's actually spherical. So the notion that Earth is just a flat plate or something is not true for antique times. And Eratosthenes in 200 BC already calculated the circumference of Earth to about 2% of accuracy. He came about up with 42,000 kilometers, which is quite close to our 39,000 and something, nearly 40,000 kilometers, which is amazing. If you are interested, I can show you the details, but I don't want to stretch your mind too much about that. But just how we think about antique times and their cosmologies, what do you think, when was this picture created? In which century? What do you think? 18th? Yeah, comes closer. It's actually end of 19th century. Because it's looking back from an Enlightenment perspective on what people in the Middle Ages were thought to believe. So it's history of the winner, so to say. They show how Christians actually, a Christian missionary sees into the heavens and so on. And yeah, so it's a meteorological work of Camille Flammarion. So I think we should really be careful about what we think about antique times. They probably knew much more than we think. They were quite intelligent people. Okay, just as an introduction, I think that should stretch your mind a bit and think differently than what usually people think about our history in view of doing research on the universe. I want to show you the immense dimensions of space. We start with man. Man has a dimension of 1 meter. Yeah, I know most of you are larger than that, but for our purposes, 1 meter is just the exact size of man. And woman, of course, too. Then when you take the distance from Berlin to Warsaw, you come up with about 600 kilometers, which is 10 to the power of 5 meters. So 10,000 meters or 100 kilometers dimension. Then when you take Europe from Portugal to Russia, you have about 10 to the 6 meters. And I ask you to keep in mind what it means to jump by a dimension of 5 orders of magnitude, from 1 meter to 10 to the 5 meters, because we will do that later again. So that means jumping from man to the distance between Berlin and Warsaw. And jumping from Berlin to Warsaw to Portugal to Russia means a jump of 10, which you can also imagine from 1 meter to 10 meter, of course. It's dimensional jumping. It's amazing. So if we go to Earth, we have again a jump of a factor of 10, about the diameter. If we take the circumference, which is more important to us, we have again a jump of 10. Then the distance Earth-Moon is again about a jump of a factor of 10. Then we jump again a factor of 10 when we take the diameter of the Sun. And we jump by a factor of 100 again when we go to the distance from Earth to Sun. It's not Su, it's Sun. So this is already 5 orders of magnitude from the diameter, from the distance from Europe, Portugal to Russia. So we have again this large dimension jump. Then when we go to the end of the solar system, we have again a jump by the factor of 10. So Earth distance to Sun taken by 10 will be the distance about to Pluto. Then jumping from our solar system to the next star that is closest to us, Alpha Centauri, we have a jump of a factor of 4 dimensions. So there's a lot of empty space in between all that. And then jumping to the Milky Way is again the same jump as if you jump from a human being to the distance of Europe, or to the spread of Europe, to the Milky Way. It's 10 to the power of 21 meters. It's just amazing, and I think that blows probably our mind if I look in your faces, and I also can't imagine that. Just a small picture of our galaxy. It has a distance of 100,000 light years. So if we take light from one side of the galaxy, it travels 100,000 years until it reaches the other side of our galaxy. And the Sun is actually placed in a very good location right here. It's not close to the center, which has a lot of radiation, but it's not to the very outskirts of our galaxy, but it's very in the middle between center and outskirts, so it has enough elements that we need for our lives. And at the same time, it's not within of the main spiral galaxy arms, but it's rather between the arms, which means we have free sky to look beyond our own galaxy. So we are able to observe the rest of the universe. It's a very good place to be, just as a side note. So Milky Way, and then we jump again by a factor of 10, then we have the distance of the Milky Way to the next galaxy, which is the Andromeda galaxy. And then we jump again by a factor of 100, we have superclusters, which is groups of galaxies that somehow form a superstructure, which does not mean that they are really connected, and there is a lot of space in between them, like 2 million light years. And then when we look, how far can we look at all in our universe? It is estimated to be about 14 billion light years, which is about the age of the universe according to the naturalistic picture. And all of this talk will be taken from the naturalistic picture, because I want to show you there are quite a few connection points within the naturalistic framework to theology, actually. So we have immense dimensions. Jacques Monod wrote in his famous work, Chance and Necessity, if he, which is human beings, man, accepts this message in its full significance, not only the vastness of the dimensions, but also how we came about by chance and necessity, man must at last wake out of his millenary dream and discover his total solitude, his fundamental isolation. He must realize that, like a gypsy, He lives on the boundary of an alien world, a world that is deaf to his music and as indifferent to his hopes as it is to his sufferings or his crimes. So complete loneliness when you just look in the vast dimensions of space. What else could we feel as human beings? You are lost. At least you know where you are lost. But there is a different interpretation of that. Like Sir John Newton, a Christian atmospheric physicist, he says, size, energy, and precision, such is the wonder and magnificence of the universe God has created. Where do these laws of nature come from? They are not invented by human brains. Rather, they are discovered because they too are part of God's creation. They are God's laws. The science humans explore is God's science. So he sees the magnificence and the size in a theistic framework. And actually, I would say both notions are also present in Psalm 8 already. For example, in verse 3 and 4, when I look at your heavens, the work of your fingers, the moon and the stars, which you have set in place. What is man that you are mindful of him, and the son of man that you care for him? So the size of the universe makes us think. Are we lost in space by the pure quantity of what surrounds us? Or can we be astonished at the greatness of the Creator that has created all this? And maybe we will see later that there is not just quantity, but it's also a question of quality. But that will be a later point. Let me come. This was the space dimension. I want to come now to the time dimension of the universe, according to the recent model of cosmology. The Unimaginable History of Time, chapter number 3. In the beginning of the 20th century, people thought that the universe is eternal and static or stationary. So the universe has no beginning, but it simply existed. Sir Arthur Eddington, an astrophysicist, for example, said, philosophically, the notion of a beginning of the present order of nature is repugnant. I should like to find a genuine loophole. We must allow evolution an infinite time to get started. So we see that behind that notion, there are worldview assumptions. And so this was the ruling picture. I don't want to explain to you and frighten you in any way, but I want to show you what is in an equation and how physics relates to an equation. There are three factors in that equation that Albert Einstein set up in 1915. This is the main equation of general relativity. It assumes that the universe is just a homogeneous fluid. That is the assumption behind that equation. And if you make this assumption, then you can do a lot of interesting calculations with that. Among others, you can postulate that there is a beginning and the universe expands, or you can also assume that the universe is static or stationary, not changing much in its size and in its structure. So one thing is the shape of space-time. This is the R's. It's actually not just one equation, but it's a tensor equation, which means that it's 10 different equations, independent equations. So the first term is the curvature of space-time. On the other hand, you have matter, which mainly interacts by gravitation, because matter on the cosmic scale is usually electrically neutral, so there is no electric force working there, it's all gravitation. And so what you see by that, if you equate that, that means that if you put matter in this term, that changes, and that has an effect and therefore changes the structure of space-time, of space and time and how they relate. That's how equations work. And hence you can develop models of how the cosmos looks like and how it could develop. So this was the equation that Einstein set up, and he realized when he does not have this term, which at first hand he didn't have, then the solution is unstable, which means it can easily collapse or expand, rather collapse. So he said, I need an additional term, and this is mathematically possible, this additional term. He inserted that, and then he got a stationary solution. So this was a peculiar thing to do, and later on he said, this was my most stupid thing to do, but today we will see later, this is a very important factor in this equation. So as time developed, there were people like Georges Lemaitre, a Catholic priest actually, and a hobby physicist who learned all that because he wanted to learn it. I wonder how many theologians are here who like general relativity and study that themselves. And he developed an expanding solution in parallel to a Russian physicist, Friedman. And when he discussed his solution, which he called the primordial atom hypothesis, because the universe would have started just in a single point. When he suggested that to Einstein, Einstein said, no way, the universe doesn't have a beginning and so on. So he was reluctant to that idea. But then evidence started to come up, like Edwin Hubble. He measured a certain type of stars and he put all the measurements together. And so he found out that actually there is a redshift to the light that we observe, and hence the universe in the past must have expanded. And then there was the microwave background, which was predicted using that equation. I don't go into the details. I hope that's fine for you. If you are interested, you can ask me afterwards, or you can read good books about that. But these two guys, they are Jewish people, Arno Penzias and Robert Wilson. They measured for telecommunication, for the Bell Labs, and they made measurements. And they somehow found an isotropic noise. And so they thought, where does that come from, that strange noise? And they discovered that doves were actually breeding in their antenna. So they removed the doves, and that reduced the isotropic noise, but it was still there. So they reported that, and just by accident, they met an astrophysicist, and they said, this is very interesting, let's check that. And in the end, it was established that this was actually the discovery of that background radiation that should be left over if the Big Bang theory is true. And Arno Penzias, who received the Nobel Prize for this discovery, and also Mr. Wilson, he said that the best data we have concerning the Big Bang are exactly what I would have predicted had I nothing to go on but the 5 books of Moses, the Psalms, and the Bible as a whole. So from his perspective, this was perfectly in convergence with the story that in the Bible that the universe has a beginning. And he confessed that, which is very peculiar. And of course, there were the atheists who were reluctant against that, as I showed you. Like John Maddox, he even wrote in the late 80s an article in Nature, Down with the Big Bang. And Big Bang is not a positive name, actually. It's just like, what do you want with your large noise there? The Big Bang, today it's a neutral term, but in those days it was actually meant to be negative. He says the Big Bang is thoroughly unacceptable because it implies an ultimate origin of our world. Or another article written in the 70s, the biggest problem with the Big Bang theory of the origin of the universe is philosophical, perhaps even theological. What was there before the Big Bang? So we can realize the unease with which that theory was met, that there is a beginning to natural order. And Bill Craig, of course, has produced a very good argument out of that, and he says, everything that begins has a cause. It's the first premise. And the second thing is, well, science shows us that our universe has a beginning. It began. So if we take these two premises, then the logical conclusion is our universe has a cause. Of course, it's a lengthy discussion. Atheists try to get rid of the beginning and so on. But I would say in the moment, it's really a valid argument for the universe to have a cause outside itself. Matter is part of our universe. So if matter should be the cause for our universe, you need to postulate several universes that also consist matter or some material mechanism outside the universe, which is very metaphysical theory. Then numbers or ideas, abstracta, they do not really have an effect normally on matter. So what is left is actually a person, a personal entity that could be the cause of the universe. If you want to read about that, look up the Kalam cosmological argument by William Lane Craig. It's on the internet, even on YouTube. There is a 5-minute introduction, which I think is a very good summary. So I told you that there is people try to find ways out. So one way out is to say, actually, we don't have just one time dimension, but we have 2 time dimensions called imaginary time. And then you don't have a point at the beginning, but a sphere or a surface in the physical diagram. But of course, you can't measure imaginary time, and that does not really solve the problem of the beginning, unfortunately. So Stephen Hawking himself says in A Brief History of Time, if the universe really is in such a quantum state, there would be no singularities in the history of the universe in imaginary time. In real time, the universe has a beginning and an end, at singularities that form a boundary to space-time. So, very sophisticated theories did not really get rid of the beginning. But they try to get around the God solution. Like Stephen Hawking in The Grand Design, he says, because there is a law of gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. It is not necessary to invoke God to light the blue touch paper and set the universe going. So he thinks that the law of gravity and quantum fluctuations and so on are the cause of the universe. The problem is that he says something about the universe comes about from nothing. But how can anything come out of nothing? Because even a quantum vacuum is not nothing. It's just a quantum vacuum which has space-time, which has energy, dynamics within the space-time, energy fluctuations. And then there are natural laws, obviously. This is much more than just nothing. So he seems to ignore that, or on purpose he uses that word somehow double-mindedly. And second, how can a cause be effective without existing already? Because he says he says that the universe spontaneously created itself out of nothing. And Keith Ward commented on that and said, we were always right to think that persons or universes who seek to pull themselves up by their own bootstraps are forever doomed to failure. I mean, that's a mythology, the Baron of Münchhausen. I don't know whether you have such a figure in English history as well. And then, of course, you always have the problem, even if such a mechanism would exist, which still is not established, it would never exclude an agent, because a mechanism is not necessarily the final answer. So if you want to read more about that, I recommend the book by John Lennox, Stephen Hawking, The Universe and God. So you see that naturalistic scientists try hard to get rid of the Big Bang. And Stephen Hawking said this, heaven is a fairy story for people afraid of the dark, and John Lennox just encountered that by saying atheism is a fairy story for those afraid of the light. It's very interesting. It's a worldview war. It's not about scientific facts. So I don't know whether you are interested in that. That would be the structure, how the universe, according to the Big Bang Theory, has developed from the beginning. Are you interested in that, or should I skip that? Okay, so we start at a singularity. Everything is concentrated in one point, which means the energy density becomes infinity. And we can't say anything about that because all our equations break down at energy or density of infinity. It's a singularity. Infinity can never be calculated. So we can only start after about 10 to the power of minus 43 seconds, which is still a very short time, but it's not zero. It's not zero. So at that time, some equations start to describe the picture of the universe. So we have the so-called gut era, which is not about the taste of that era, but it's the grand unified theory era, which means that there are four basic forces in the universe: strong force and weak force, which are all active within the nucleus of the atom. And then we have the electromagnetic force and the gravitational force. And in the gut era, or good era, the strong force becomes then distinct from the other forces after they had been united at the beginning of the universe. And the big question is whether gravitational force also could be united to these threes or not. And that's the search for the theory of everything, actually, for that formula that unites all forces that we know in physics. So, okay, we have this. Then first elementary particles developed. We come to, and the universe, as it expands, of course, gets cooler and cooler, which means that the energy density within the universe gets lower and lower, which means when you cool something down, things can freeze out, symmetries can be broken and so on. So it's all about symmetries broken, energy density becomes thinner and thinner, and so structures evolve, so to say. So we arrive at elementary particles. They combine to protons, and just see that, it's still day one, actually. It's after 3 minutes, protons, neutrons, electrons, neutrinos. All developed from that equation when you go back in time with that equation. Then you get a plasma of hydrogen and helium, of nuclei plus electrons, but they are not yet combined. So light can actually not move very far, because as soon as it hits a charged particle, a nucleus or an electron, it will be absorbed and the energy is gone already. So you can't see anything there if you sit in that kind of plasma. You wouldn't sit there anyway, I think. So after about 300,000 years, suddenly atoms form and the plasma becomes transparent. The electrons stick to the nucleus because it's cold enough that they are not ripped away all the time. So they combine, and it's electrically neutral. So light can spread out. And that's actually what we call the microwave background. It comes from that point of time when light and darkness were separated, actually, at that point of time. Then we have atoms and plasma, and stars begin to form, a first generation of stars, a second generation of stars, and within the stars the heavy elements are produced according to that theory, and then step by step the stars together form galaxies because of gravitational forms. They rotate about centers or somehow build each other up from supernova and so on. So this is the era in which we live now. It started about 1 billion years ago and lasts until present. And human beings just are here for a very tiny time. If you compare it to 3.8 billion years or 3.7 billion years, doesn't matter to shift a few million years in that picture. But you just got a little taste of what's that all about, cosmology. Yeah, so we saw space, we saw time and the vast dimensions, and I showed you already that a single equation leads us into understanding all this. And Albert Einstein actually was intrigued by that. He says the most incomprehensible thing about the world is that it is at all comprehensible. That is the inverse Socrates. He says, I know that I don't know. And he says, I know, but I don't know why I know. So I think that is very interesting. And the Nobel Prize winner Eugene Wigner, he said that the miracle of the appropriateness of the language of mathematics for the formulation of the laws of physics is a wonderful gift which we neither understand nor deserve. He's an agnostic, by the way, from Jewish background. And one example for this would be that the physicist Dirac actually used the quantum mechanical equation and combined it with Einstein's special relativity, and he came up with a solution and said there must be antimatter. No one had an idea that this should exist before, but his solutions suggested there must be antimatter. So they set up experiments, and 3 years later they came across the anti-electron, the so-called positron. So for some reason, nature seems to conform to mathematical equations, and that's just amazing, because 1 + 1 would be 2 even if the Big Bang had never happened. But nature somehow likes mathematics, and mathematics is like a key. You get a bunch of keys, and you have a castle, and you need to go through all the doors, and you take one key, stick it in, wow, it fits. There are 100 keys, but it fits. And so it's like that notion, and we don't know why these keys always fit with nature. Then another thing, nature seems to be have a structure that favors us to discover. I told you about our position within the galaxy already. But when you, for example, look at our neighborhood in our planet system, like Moon and Sun, they are very different in their diameter, actually. But interestingly, their distance to Earth is exactly at the same ratio. So what that means is if you look into the sky, then you have them at the same diameter at the sky, which means it is possible that the Moon can completely overshadow the Sun, depending on its exact distance, which varies from time to time. So sometimes you see everything around the Moon, which is very important for physics because you can analyze the corona of the Sun which you usually can't because the other light is too strong. And the same way, the same other way as well. And this was very helpful for understanding our planetary system, understanding the sun and the moon. And then the question is, why can we think and understand all together? Like the geneticist Haldane, he said, it should read geneticist actually. It seems to me immensely unlikely that mind is a mere byproduct of matter. For if my mental processes are determined wholly by the motions of atoms in my brain, I have no reason to suppose that my beliefs are true. They may be sound chemically, but that does not make them sound logically. And hence, I have no reason for supposing my brain to be composed of atoms, because that's only a theory made up by my brain. So we really have this big puzzle, the mystery of the incomprehensible comprehensiveness of the universe. And of course, within Christian theism, we have this search for truth, for veritas in Latin, which is engraved in the Harvard University, which says there are 3 books of veritas. It's God's word, it's scripture, revelation, then it's God's works, nature, and it's God's thoughts, mind, logic, mathematics, and so on. And all this can be used, and God did not put us here just to torture us or whatever, but to understand what He has created and to appreciate it. And so for a Christian, it's just perfectly normal to assume that it is logical that we can understand nature and comprehend it. So there's a reason, because we all have been created by the same God who had good purposes for us and for the universe. The materialist really is just standing in front of a big mystery, which is astonishing. Okay, we've come to the next chapter. So when we look at the structure of the universe, not just time and space and the mathematical description of it, we find out that the universe obviously is created in a way, or has evolved in a way, or whatever you want to frame it, that intelligent beings can exist. And the question that I want to ask you is, how is the universe expanding? Because if you think about something that is expanding, it could expand forever and become slower and slower, but expand forever. It could become faster and faster, or it could expand and then collapse again. Or it could be static, but a static solution is very unstable, so Einstein is still right on that. And so these are the different models, how the diameter of the universe could evolve over time. And when you think about it logically, just compare it to a balloon, like the universe is the skin of the balloon. It's not the balloon as a whole, but it's the skin of the balloon. And you pump air in the balloon. The larger it gets, the slower it expands, actually, because of the elasticity of the balloon skin. The elasticity of the balloon skin would correspond to the gravitational force which attracts the masses, the galaxies. So we would expect, actually, that the universe should be decelerated and become slower and slower from time to time. But what we found out is, actually, when we make certain measurements for which the Nobel Prize was awarded in 2011, that actually the expansion gets faster and faster. It gets accelerated, which is counterintuitive. So the only explanation is that vacuum energy density is bigger and larger than matter energy density, than gravitational force. This is gravitation, and this is stretching out the universe. And this is actually now where Einstein's lambda comes back in again, which was disputed whether that's a stupid thing to insert or not. But now we need it because of our measurements. We don't know what this so-called dark energy, it's called dark because we don't see it, we have no clue what it is, what power is behind that. It would be a fifth force, so it's sometimes called the quintessence, the fifth element, so to say. And when you look at that dark energy, it's a constant in the equations of Einstein, if you remember that, the lambda. You can fiddle around with the value of that constant. And if you change the value of that constant, just by a very tiny amount, by 1 to 10 to the power of 60, which means 0 dot, and then you have 59 zeros, and then a 1. You can count it. I don't know. I think it's too little. just change it by that value, even to positive or to negative values, you will realize that there is no possibility for life to exist, because either the universe would have collapsed after a few years or a few days or seconds, depending how large you change the value, or it would have expanded at a much too high rate so that stars or even atoms could never have formed. And of course, we must assume that atoms and stars are a prerequisite for human life, intelligent life, or life as a whole to exist at all. So this is an amazing fine-tuning, so to say, the most extreme fine-tuning problem known in physics, as the atheist astrophysicist Lawrence Krauss writes in a publication. And Paul Davies, another astrophysicist, he calculated the accuracy, or he tried to compare it, and he said, if you compare that to the probability of hitting a 1 cent coin, it's Münze there, no, it should be coin, I'm sorry, that's a German word for, at the other end of the universe, and you try to hit it with your gun, as this squirrel is doing, then this is exactly the accuracy. Because the surface of the cent piece, of the cent coin, would exactly be the same part compared to the surface of the universe as 0.0001, the accuracy of the fine-tuning of the dark energy. So there is the fine-tuning of the universe, but there is also the fine-tuning of the system Sun-Earth, which is fit for life. Like the galaxy, the right size, the right position, the sun mass and luminosity, Earth, the axis of the Earth, the distance to the sun, the rotation period, magnetic field of the Earth, which is very important to shield off charged particles that would destroy life, and then the moon that stabilizes the axis of the Earth, and Jupiter, who allows us to have very little comets or meteorites to arrive on the surface of Earth. And then the two things, the terrestrial and the universal fine-tuning, come together in this very interesting point. Because when you look at the spectrum of the sun, it has a radiation maximum in visible light. And this is exactly that region of light that is necessary so that organic molecules can use the energy for photosynthesis, which is a basic ingredient of life. And the energy that is used for photosynthesis is determined by the universal force constants. So it is only possible to do photosynthesis if you can move the outer electrons of molecules. And they have these binding energies. And solar light just can be absorbed by these outer electrons. So it's just amazing that this is fitting. If the sun had a different spread of radiation, it might be much more difficult to have organisms capable of photosynthesis. So what comes out of that is the universe must exhibit exactly those properties that allow for the existence of intelligent observers. Because otherwise we would not be here, of course. But that's not the explanation why the fine-tuning is there from the beginning, and what caused the fine-tuning, because we are not the causers of the universe, but we are caused by the universe in that picture. So that's not the solution. And actually an argument can be made from that, a philosophical argument. You could say that a contingent system, contingent always means it could be different, but it is as it is, but we don't know why. It's not necessary that it is as it is. A contingent system, which is composed of independent factors, like different forces, or the terrestrial factors, working together as a system, so they somehow work together and interact, and yielding a purpose that is not inherent in the single composites, is intelligently caused normally. Like such a structure, you would never guess that this is caused by wind power or something, and neither are other such structures. So the system, universe, Earth, life, human, is such a system that is contingent, composed of independent factors, working together for a purpose, and then the universe should be intelligently caused. It would be an exception if that system was not intelligently caused, to our general experience, actually. So how do we get around that when you are a naturalist? If you have a very high accuracy or a low probability, you must throw the dice more often, of course. And hence, what is done is there must be more than one universe. We are not the only universe, but there is an infinite amount of universes or very many universes. But of course, this is a metaphysical theory. These are not observable. Then within every universe, again, you have the same low conditional probability to arrive at a Sun-Earth system, for example. And again, if you have a mechanism that produces fine-tuned universes all the time, or that allows for a fine-tuned universe as ours, the question is whether this mechanism is maybe also fine-tuned, because it could produce the same universes all the time, too, and doesn't have to go through all parameters and so on. Whatever, John Polkinghorne says, he's a physicist and an Anglican priest, let us recognize these speculations for what they are. They are not physics, but in the strictest sense, metaphysics. There is no purely scientific reason to believe in an ensemble of universes. By construction, these other worlds are unknowable by us. A possible explanation of equal intellectual respectability, and to my mind, greater economy and elegance, would be that this one world is the way it is, because it is the creation of the will of a creator who purposes that it should be so. Okay. So we come to the last chapter, and maybe I skip some of that, the dark sides of cosmology. I find your lack of faith disturbing. Would be a nice t-shirt to wear for a theologian, maybe. I have already mentioned the dark energy. This must be postulated because of the observations, and to fit the observations to Einstein's equation. Then there is another thing, dark matter. When we observe galaxies, we also can measure the velocity with which the stars circulate and rotate around the center. And what we actually would expect from a planet-like rotation would be the lower picture. But what we observe is the upper, the wheel-like rotation, like as it would be a solid a disk. Because the outer parts rotate faster than the inner parts, different from the planets. And what that means is that the mass cannot be concentrated mainly in the center, but it must be spread out over all of the galactical disk. But that means when we compare that to what we see from the galaxy, we see that the mass that we see is in the center and only little mass is outside. So what's the solution? There must be additional mass that does not interact with light, because it does not shield the light of these stars, and at the same time it does not send out light. So it does not interact at all with light. But the problem is we only get light from the universe. So it's not easy. There must be matter which is not visible and not interacting with light. And that's actually what is called dark matter. There's another effect that is called gravitational lensing. If you are interested, I explain it to you afterwards. Dark matter, yeah. When is science going to explain the dark matter I find in my belly button every morning? That's a big question. And actually, when you take all that together, dark energy, dark matter, and our conventional matter, we can estimate about the proportions, and we find out that 70% of the universe is actually dark energy, which is this whole piece of the cake of all energy in the universe. Then 25% of the energy of the universe is dark matter, which does not leave a whole lot for what we consider to be our universe, because we interact with it. This is hydrogen, stars, neutrinos, heavy elements. That's what we can see and what we touch and what we are made of right now here. So it's really interesting how the observations of the cosmos force us, if we want to apply the Einstein's equation, to arrive at this picture of the universe. Most of the picture of the universe is just dark energy and dark matter. If you only take the matter part, then 80% of the matter, this is no matter, this is the vacuum energy density. 80% of the matter is dark matter. Only 20% is our visible matter. Yeah, so I think I will skip the inflationary era, but I will just shortly explain you what the problem is. Another thing that you might have noted is this strange funnel here, because actually it should expand rather homogeneously. But this causes big problems in the symmetry and in the equilibrium of the universe as we observe it. And hence we need to postulate that right at the beginning, after about 10 to the power of 35 or 36 seconds, there was an era in which the universe suddenly started to expand at an amazing speed and then slowed down again. And we don't know which force caused that again. But it must be so, otherwise we cannot get the equilibrium properties in the universe that we observe. But this is a detail, it just shows you that there are some skeletons in the cupboard of modern cosmology. Dark energy, dark matter, inflationary era. Yeah, I skip all that. It's for physicists probably. So I want to come to my last point. Just a few ideas of what we can make of cosmology in the naturalistic picture when we approach it as Christian theologians. First of all, what we see is the universe had a beginning in Genesis 1, and cosmology, after a long struggle that lasted over several decades, confirms that there is a beginning, and cosmologists are still testing that beginning. Stephen Hawking has tried it, and others are also trying to do that. Then the Bible talks a lot about stretching out of the heavens. The physicist Hugh Ross interprets that in a way that the universe is expanding and has been expanding. If you read Isaiah 40:22, then it is twofold. It says, has been expanding and is expanding still. So he would say this is just a description of the expansion of the cosmos in the Big Bang Theory. Of course, you need to think whether this is eisegesis or whether it is exegesis. I leave it up to you as theologians to think about that. Then the question of the multiverse. This is the challenge of the naturalists to get rid of the fine-tuning problem by higher probabilities. It has been suggested that in the Bible, shamayim, which means heavens, is actually always in the plural. So why should not God even create more than just one universe? I don't know whether theology puts any restrictions on that. If it turned out that for some reasons we could prove that there are multiverses, which right now we can't do. And then what we see from cosmology is that there is a unity in everything, but in hierarchical structures. You could compare that to Ephesians 4. We are one, but in many parts and with different functions and so on. So when you look at the fine-tuning, there are different particles and different forces responsible for different things. And there is a hierarchical structure of the universe, like planets, stars, galaxies, galaxy clusters, galaxy superclusters. And so it's not just an unstructured order, a chaos, but it's a hierarchical order. And I would say that Genesis also presents us with a hierarchical order of the universe. Another thing is the ingenuity of God versus the limitations of science. When we read Isaiah 55, we just must come to the conclusion that if God's thoughts are higher than our thoughts, we cannot understand everything about the universe, and that there are dark matters within the universe might be an expression of that God's thoughts are just so much beyond our own possibilities. I leave out that point because I skipped over that. That would be more going into quantum mechanics, that information might be the prime size of the universe and not matter, that matter conforms to information. There is some indication for that. God gave laws to nature which man can understand. This is the problem of the incomprehensible comprehensiveness. And God wanted us to be here to rule over creation, if you read Ephesians, for example. And this is confirmed by the extraordinary fine-tuning and the Anthropic principle, actually. We would expect something like that. But of course there are challenges. And depending on the theological branch that you personally favor, I don't know whether you have one opinion altogether here or whether you have different ways of thinking about that. There are young Earth creationists, there are old Earth creationists, there are theistic evolutionists. And they would all interpret the Genesis account in a different way. And so the age of the universe is, of course, a challenge if you are a young Earth person. They have tried to come up with some models, but it is, of course, right now, there is no viable option right now that explains it in a plausible way. So there's still work to be done, but science is always an open process. So I would never say, don't go for that option. But yeah, if you want to show that this option is compatible, you need to develop predictions that can be compared to what we have found out right now about the data of the universe. And of course, this is a large research project, I would say. But of course, others would disagree that this is taught in the Bible at all. So I leave that up to you theologians. But we as scientists would be happy to get some advice from you, what you think about that. And then depending on that problem of the age is of course a second problem of suffering. The universe is just matter, so that's fine. But what about if the whole theory of the slow development of the universe is true? What about the suffering of innocent animals, for example, and physical death before the fall of man? Does that fit with the biblical description, or does it not? I mean, that's an interesting question, and I've seen that there are contradicting books on the science bookstore table, actually, tackling this question differently. So that would be an interesting thing for you theologians to analyze. And then, of course, there's the problem of reductionism. The whole theory of the Big Bang actually rests on the assumption that everything that we see today can be reduced to a single unified natural order. That is the basic assumption of naturalism. And there is no interference of God with that order. There is one bottom-up equation that starts and describes the whole universe from the beginning, and then everything actually is caused by the forces that enter into that equation. So it's materialism, actually. And the question is whether this is the picture that the Bible gives us of a God who obviously interferes at the acts of creation and even beyond that. And then there are these tries to avoid a singularity at the beginning to get a self-contained universe and so on. But they have big problems right now. And still I would say that a Christian can really love cosmology, no matter of which denomination or Genesis 1 confession the Christian comes. Because I think we have quite a bit of apologetic value in what cosmology has found out. We have the quantity lost in space versus the quality, the intentionality that we find through the fine-tuning. Then we have the acceptance of the beginning. We have the acceptance of the fine-tuned universe, which people try to sort out by believing in an infinite number of universes in the multiverse. And then we have the mathematical beauty of the symmetries, which indicates that rationality and logic might play an important part in explaining matter, which has no reason or no cause when you are a materialist. And of course, there are open questions like dark matter, dark energy, inflation, also some extrapolations from the equations and the many parameters that play a role. So there is still room to go for different theories. And even in the secular camp, there are people who follow different theories than just the standard Big Bang theory. But up to now, I would say, if you look at cosmology, there is not yet a serious alternative that fits the data in a similar persuasive way as it does Big Bang cosmology right now. Of course, it depends how large the problem of dark matter and dark energy and so on is taken, which takes 95% of the universe. So yeah, the question for the scientists are, is there an alternative? Is it necessary? What is the age of matter? And so on. Yeah, so I've tried for you to put the universe together in the right order. This is how Germans would sort this out. This opens up the space for discussion. Thank you for following my thoughts as a scientist. I hope I did not get you to sleep somehow, but that you could understand the basic principles that I want to transfer to you. Thank you.